Hello, I'm now going to go through the procedural programming you've got to know about for OCR A-Level. And it's very tempting, especially when you see the title, Programming Basics, to just skip past all of this because you feel like you know it already. And you may well know lots of it already, but there will be some things perhaps which have slipped through the net. And don't forget, if you've got to know OCR pseudocode, you don't have to write it in the exam. You can write Python or Java or C#, but you've got to understand their pseudocode. And there'll be some concepts in their pseudocode which aren't in your normal programming language. For example, constants we're going to talk about today, which aren't in Python. Now, variables are in every language. A variable, you might have to define this, is an identifier that represents a location in memory, which holds a value that can be changed. The word identifier refers to the name we give something. We also give names to subroutines and arrays and so on. These always have to be one word and they can't start with a number. Variable assignment is what we call associating a value with an identifier. And we use the equal sign to do that in pretty much, most programming languages. So here we are assigning 3 examples of assignment here. And this line here, we often see and is a bit confusing to look at. Score equals score plus level 1 points. It's confusing because it's not using equals in the way which means equals. All that it's saying is set the new value of score to be equal to the old value of score plus level 1 points. So equals means assignment, doesn't mean equality. I've got a print line there. Print will just be used to output messages on screen to the user. Now we use inputs to get messages from the user. And it's important that we are always assigning user inputs to variables straight away. So here I'm asking the user to enter the city they're in. I am also straight away assigning it to be equal to a variable called city. Then I'm printing what the user typed in. That's how you're meant to do it. What you're not meant to do is just have inputs floating like that example, because the user types in an input and it's not being saved anywhere. And likewise, this also shows another misconception where London is what I've put in the brackets of input. What should go in the brackets of input is the prompt. A prompt is a message which goes to the user. The user then types something in and gets saved under a variable. We don't put in what we want the user to type in the brackets. It's a message saying what they should type in, and they can type in what they want, and then we save it as a variable. Constants might be the first concept in this video which you're not that familiar with. A constant is an identifier that represents a location in memory which holds a value that cannot be changed. And that last bit is the only difference between that definition and that of a variable. Constants can't be changed once they are first assigned. But in pseudocode, you might see the const keyword being used before the identifier name. And conventionally, programmers often put constant identifiers in capital letters. You don't have to. Often they are capitalized to tell anyone looking at them that is a constant. It shouldn't be changed. So here, I'm setting the exchange rate to be 1.27. I'm also setting a variable called pounds. I'm multiplying the two together, which is fine. And we would get, in this case, that output. However, if I tried to then later on in my code reassign the value of exchange rate, I would get an error because constants can't be changed once they are first set. Now that value isn't locked in forever. I can just change it before I run it again. The key thing is that once it runs, it is then locked in for that single runtime. Which begs the question why you might decide to use a constant in your program. Well, we use it to try and prevent values changing by mistake when they shouldn't change at all. Some values have got no reason to change. Therefore, why would you open up the possibility that someone could change it by mistake? And that could well happen in a big development team with lots of different programmers working on the same program. It also, if we are maybe imagining a massive program, it also can make the code a little bit more readable, because if you see exchange rate and you know it's a constant, you know exactly what value it's going to hold. You also, if you see capitalized variables, you can assume they are constants. And it means you don't have to hunt around looking for what value they hold. You go to the top, you see, okay, right, that's set to 1.27. You understand straight away that that value is going to be the same throughout the entirety of the program. And the alternative to using a constant might just be to dot around 1.27 everywhere. Like this exchange rate might be used multiple times in this program. You could just replace the constant with the actual literal value, 1.27. But if it does need updating, which an exchange rate may well update, we only need to update it in one place. All we need to do, if the exchange rate changes, is modify the first assignment. You don't have to modify it in 7 different places like you might have to if you're using the literal value 1.27 dotted about. We mentioned in the stages of compilation video that compilers do optimization, where they're trying to make the code run faster or use less memory space. And they can do some optimization with constants. For example, they might substitute the constant with the literal value 1.27, and that will prevent a memory lookup. It won't have to look up what that means in memory every time it's using exchange rate, which would save a bit of time and so allows it to optimize a tiny bit. And the last thing we'll go through in this video are the data types. These might be described as the primitive data types, and there are 5 you've got to know about: integer, real, boolean, character, and string. Data types are categories for data. They determine how the value gets stored in binary and also the operators you are allowed to use with it. For example, integers and reals might be stored using the kind of binary denary conversions we look at later in the course. Character might be stored using ASCII. Boolean might be stored using either 1 or 0. They're all stored in different ways, and there are different operators. For example, you can use multiplication with integers and reals. You can use concatenation with characters. It varies depending on the data type. And they're called primitive because these are our 5 basic ones. There are some what are sometimes called composite data types, which are things like data structures, arrays, lists, hash tables, things like that. These are our 5 fundamental ones. Integers and reals are our 2 number data types. An integer is a whole number, whereas a real, also called a float, has a fractional part. Boolean values only have one of 2 possible values, either true or false. A character is a single letter, number, or symbol in your character set, like ASCII or Unicode. We always put quotation marks around both characters and strings. Strings are a sequence of characters. And we often have to cast between data types, especially when dealing with user input. Casting is changing data type. Here are the 3 most useful casting functions. We can convert it into different data types. Again, often with user input, we're going from a string into an integer or a real. And often if we're concatenating, we might need to convert a number into a string.